In this video, I want to solve, again, this is a problem that we could do much easier just using the methods of chapter 4. But what I want to do is I want to solve the initial condition x double prime minus 4x equals 3t, given the initial conditions that x of 0 is 1 and x prime of 0 is also 1. And so we'll start by taking the transform of both sides. And since we've done this numerous times, I'm just going to do it. We're just going to do it all in one step. So if I take the transform of the left side, we'll end up with s squared capital X of s minus s times little x of 0 minus x prime of 0 minus 4 capital X of s equals 3t. So the Laplace transform of 3t is going to end up being 1 over s squared. So this will be 3 over s squared. And we have that x of 0 is 1 and x prime of 0 is 1. So that tells us that we're going to have s squared times capital X minus s minus 1 minus 4 capital X is going to be equal to 3 over s squared. So that tells us that capital X, if we factor out an s squared minus 4, is going to be equal to s plus 1 plus 3 over s squared. And let's see, next, that tells us that capital X, capital X, capital X is going to be equal to s plus 1 over s squared minus 4 plus 3 over s squared times s squared minus 4. And so what that means is that we're going to have all right, time in here. So that means that we're going to have, we can rewrite this as s over s squared, s over, let's take that again. Take 2. 3 really, take 3. So that means that what we're going to have is capital X is going to be s over s squared minus 4 plus 1 over s squared minus 4 plus 3 over s squared times s squared minus 4. And in fact, this last term, what we can do and what we're going to have to do is a partial fraction decomposition. And so what we're going to end up with, there's a few different ways to do this, but what we're going to end up with is we'll have something of the form as plus b, and then s squared minus 4 factors as s minus 2 times s plus 2. So C and D. And so what we're going to do is, let's off to the side now, before we continue, look at the partial fraction decomposition there. So I want to find those constants A, B, C, and D. So what we're going to do is let's set those equal, multiply by, we'll multiply by our denominator. So we have 3 over s squared times s squared minus 4 is equal to as plus b over s squared plus c over s minus 2 plus d over s plus 2. And if we multiply both sides by s squared times the quantity s squared minus 4, we'll end up with 3 being equal to as plus b times s minus 2 times s plus 2 plus cs squared times s plus 2 plus ds squared times s minus 2. In this case, because it's such a high degree polynomial, because there was a lot of terms to cancel. You could do the trick that we did before where you have a third degree polynomial on each side, set the coefficients equal. That's totally fine. I think in this case it's actually easier. I think it's easier in this case just to actually plug in some values. So if we plug in, say, s equals 0, what's going to happen is our left side's a constant 3. So no matter what s value we plug in, our left side will be 3. But at the right side, if we plug in s equals 0, is going to give us b times negative 2 times 2 is negative 4 plus 0. So this tells us right away, this tells us straight away b is negative 3/4. If we plug in s equals 2, then everything's going to cancel except for the c term. So that's going to imply that 3 is equal to c times 2 squared times 2 plus 2. So that's 4 squared times 4, 16c. So c is going to be 3/16. If we plug in negative 2, all the s plus 2's are going to cancel. And what we're left with then, we'll have 3 on the left side. We'll have this term and this term cancel. All we're going to have left is the term with the d in it. So this is going to be 4d times negative 4. So negative 16d, which means the d will be negative 3/16. Finally, we need a. To get a, we're just going to plug in any other value. I'm just going to pick 1 because it's nice and small and straightforward. So if we plug in s equals 1 on the left, we'll get 3. On the right side, we're going to end up with 1a plus b times, if s is equal to 1, we'll have s minus 2 is negative 1, s plus 2 is 3, plus c times 1 squared times 3, plus d times 1 squared times negative 1. So this tells us, let's see, that 3 is going to be equal to negative 3 times the quantity a plus b plus 3c minus d. And at this point, what we can do is we can, if you want, I think it might be easiest just to divide both sides by 3. This is just a matter of taste, but that gets rid of most of the 3's, which should help a little bit. This does put a fraction there next to d, but the reason why I don't really care is that I know that d is a multiple of, at least it has a numerator that's a multiple of 3, so that 1/3 is going to end up canceling in a nice way anyway. So this tells us that 1 is going to be equal to negative a minus b, we said b was negative 3/4, plus c, that's 3/16, minus 1/3 d, which we said was negative 3/16. So that tells us that a, I'm going to add a to both sides. I'm going to subtract 1 from both sides. We're going to get a is equal to negative 1. And then, so now I've just switched these two terms and changed their signs. And I'll cancel the rest. We'll get plus 3/4 plus 3/16 plus 1/16. And it turns out that if you add 3/16 and 1/16, you get 4/16, which is 1/4. And if you take 1/4 and add it to 3/4, you get 1. And so if we add all of that to negative 1, we get 0. So a is 0. Okay, so there's our values that we had to work decently hard for. Okay, and there's our coefficients. Now what we're going to do with that is, if you remember, we want to take these values and plug them into our partial fraction decomposition. So what we're going to do then, let me zoom out just a second. What we're going to do is we're going to rewrite our transform, capital X. So capital X of s is going to be equal to 1 over s squared, s over s squared minus 4. So s over s squared minus 4 plus 1 over s squared minus 4 plus as plus b over s squared. Remember, a is 0, b is negative 3/4, so we'll get negative 3/4 over s squared, plus, I just want to make sure to put this on the right spots here, c over s minus 2. C was positive 3 over 16. That was over s minus 2. And then minus 3 over 16 over s plus 2. So here our s, here our d, was negative 3 over 16. And now we're ready. If you want, if you're up for it, we could have also really grouped these two together. I just want to point out that there's no real advantage or disadvantage of doing that there, but whatever your preference is fine. So it turns out that little x of t is going to be the inverse Laplace transform. It's going to be the inverse Laplace transform of this mess on the right that we have. So if I have s over s squared minus 4, that's going to be cosh 2t. And if we have 1 over s squared minus 4, I can really think of that as being 2 times 1/2. So 1/2 times 2 over s squared minus 4. So that's 1/2 sinh of 2t minus 3/4 over s squared. So this will be minus 3/4 t plus 3 over 16 divided by s minus 2. So that's 3 over 16 e to the 2t minus 3 over 16 e to the negative 2t. And that's quite a mess. The cosh 2t and sinh 2t are really just linear combinations of e to the 2t and e to the negative 2t. And so if you want to, you can incorporate all of those together, right? So you can have your cosine split up into the e to the 2t plus e to the negative 2t, and same with sine, right? You can add all those up and you get whatever value you get, but I'm fine with stopping here.